Hey everyone, I want to go ahead and finish up what we were doing yesterday. And I want to just do a quick review first of the 4 things that we went over yesterday. We talked about the vertical horizontal shift as well as reflecting over the Y and X axes. Okay, so I'll start with the vertical shift, and I'm going to abbreviate that with just VS for vertical shift. And remember, our rule for that was you're just going to take your function, your new function g of x is just going to be your old function, or the function that you started with, and you're going to add some value to that, and we just call that k, right? So if k is positive, you're going to shift up. If k is negative, you're going to shift down. Okay? Again, with vertical shift, you're just tacking that number on the end. With the horizontal shift, we're taking g of x, and we are substituting in for x. We're doing x minus h. So if h itself is positive, then we shift to the left, but if h is negative, we shift to the right. And remember, that's because this sign here will affect this one here. So if h is positive, it keeps that negative here, which shifts it to the left. But if h itself is negative, it would change the sign between them to a positive and shift it to the right. Okay, so that is the quick review of the vertical and horizontal shift. Horizontal shift is one that's a little bit trickier, where you have to be a little bit more careful. Vertical shift is pretty straightforward. Remember, when we are reflecting over the y-axis, okay, all we're doing is taking our function g of x, and we're replacing x with negative x. So wherever you see an x, you're just changing the sign to negative. Okay, when we are reflecting over the x-axis, remember, we are negating the entire side of the equation. So we're changing the entire thing. Negative f of x. Okay, so just a quick review there. I just wanted to go over that really briefly. If you have any questions on that, don't hesitate to ask me. I know that horizontal shift, it gets a little bit tricky, so make sure that you're okay with that, because that will be on the quiz next week. I do want to go over some other things that we didn't have the opportunity to go over yesterday. And it's still in that same idea of doing translations. It's just if you have a different starting point. So for example, if you are starting with a table, the first thing we have to do is find the equation that goes with the data in that table before we can actually do any sort of transformation. So with our table, we have our x and y values here. In order to find the linear function, or the equation of the line generated from that table, we need 2 things. We need the slope and the y-intercept. So this is going back to some algebra that you did previously. The first thing we're going to figure out is the slope. Is the slope. Okay, remember that the formula for slope, we use m as our abbreviation for slope, and we're doing the change in y over the change in x. Okay, so let's look at our y values here and here. So if we do 1 minus 0, right, we're doing this one minus this one, then I have to do the same order up here. So I would then have 0 minus negative 2. Okay, when I simplify that, I would end up with 1 over 0 plus 2, which is just 2 in the denominator. So our slope here is 1/2. And then we also need our y-intercept. And our y-intercept is where x is 0. So our y-intercept would fall here. Our y-intercept is actually 1. Okay, so the equation of our line, if we use the format y equals mx plus b, okay, then the equation of this line is going to be y equals 1/2 x plus 1. So we need to find that first before we can do any sort of transformation. So now we're going to go ahead and reflect across the x-axis. Remember, when we reflect across the x-axis, we are negating the entire equation. Okay, so we're negating the entire equation. So I'm taking this equation over here and I'm negating the whole thing. So I have negative 1/2 x plus 1. And so when I distribute that negative, I end up with negative 1/2 x minus 1. And that is my final answer here. Okay, so there's a couple of steps involved with that. You have to make sure that you first get the equation of your line, finding your slope and your y-intercept, and then go ahead and perform the operation that it's asking you to do. Okay. The last two things we're going to talk about are stretches and compressions. I'm going to start with the vertical stretch. Okay, with vertical, and I'm starting with this one because it's a little bit easier. All you're going to do is whatever that value is, whatever you are either stretching or compressing by, you're just going to take that and multiply the entire function by that value. If that a value is greater than 1, it's going to be a stretch. It's going to stretch away from the x-axis. If that a value is between 0 and 1, if it's a fraction or a decimal, it's going to compress and it's going to go toward the x-axis. So this blue line here is the line that we start with. Okay, then when we multiply it by a, in this particular example, this is a stretch because it's stretching it away from the x-axis. The x-axis is down here and it's going farther away from it. Okay? If it were a compression, then that line would come this way because it would come closer to the x-axis. So in this particular problem, we're doing a vertical compression by a factor of 1/4. I know it's a compression because this a value is less than 1. And if I just follow the rule, I'm doing g of x is equal to a times f of x. Okay, my a value is my factor here of 1/4. So I have 1/4 times f of x. F of x is 3x plus 2. So if I distribute that, I'm just going to write it over here. If I distribute that, I end up with 3/4 x plus 2/4, or 1/2. So all I did was distribute that 1/4 to both of those terms. And that would be my final answer. So vertical compression is pretty straightforward, just taking whatever that value is, that factor that they give you, whether it's a stretch or a compression, and you're just going to multiply it by the entire equation. Okay? Now, the next one is where it's a little bit more involved. It's just a tiny bit trickier. So it just involves 1 or 2 extra steps. Just like the horizontal shift was a little bit trickier, the horizontal stretch and compression is a tiny bit trickier. Okay, but if you just take it slow, you'll be just fine. So if you see here, this is doing something a little bit different. It's taking whatever the x value is and it's multiplying it by a factor of 1/b. Okay, again, if b itself is greater than 1, you're stretching away from the y-axis. If it's between 0 and 1, you're getting closer, or you're compressing towards the y-axis. Now, this is kind of counterintuitive, okay? If b is greater than 1, then you end up with 1/b here. So let's just say, for example, b is 2. If b is 2, then 1/b is going to be 1/2. Okay? 1/2 is going to make that stretch away from the y-axis because it's going to be half of the original value, so it's going to get closer to the x-axis. Okay? However, if b is a fraction, let's say, for example, b is 1/4. Okay, then 1 over b, so this is where you have to be really careful. 1 over b is going to be 1 divided by 1/4. Okay, 1 divided by 1/4, let me write it like this. 1 divided by 1/4, remember that division is just multiplying by the reciprocal. So that would be the same as 1 times 4, take the reciprocal of 1/4, and so then you would end up with 4. Okay, so when we would put that in, that would bring us closer, that would put us up here, closer to the y-axis, getting us farther away from the x-axis. Okay, so that's the difference here. It's kind of counterintuitive. It's sort of opposite of what you would expect. So you have to be really careful. Let's go through this example problem. Here we're doing a horizontal compression of a factor of 1/3. So my equation, I have g of x, right? And I'm doing this right here, this scale factor of 1/3. So I end up with f of 1 over 1/3 x. I need a little x in there. Hold on one second. I just forgot my x right here. Okay. I need my x. So here's my x right there. Okay. And all that means is if I simplify that, let me rewrite that because that didn't come out quite right. I'm going to rewrite that whole thing. Okay, I have 1 over 1, there we go, 1 over 1/3 x. Okay, and when I go ahead and simplify that, just like I did over here, that would give me f of 3x. Okay, all that means is in this original equation, wherever I see an x, I'm replacing it with 3x. So gx now becomes 2 times 3x minus 1. And so g of x then becomes 6x minus 1. Okay, so once you have that part figured out, you're taking whatever is inside the parentheses and plugging that in for x back in the original equation. So that is how you do those problems. If you have any questions, please feel free to reach out to me. Now, just a quick review here. So tonight's assignment is to finish the sheet from yesterday. Okay, so you don't have to go on to the next thing. I think it was 1.8. You don't need to go and do that. You're just going to complete the sheet from yesterday, which was lesson 1-3, transforming linear functions. That's the only sheet that you need to complete. You can complete that tonight. Now, if you don't have a chance to get to it today and you're busy or you're already headed out of town for the holiday weekend or whatever, as long as you have it to me by Tuesday morning, you're good to go. Okay, but if you can get it done today, I would certainly do that. But go ahead and try to get it done. If not, you certainly have until Tuesday morning. Okay, I'm here today. If you have any questions, feel free to reach out. And I will get back to you. I'm here all morning. The afternoon I'm busy, but I'm here through noon. So just let me know if you need anything. Otherwise, have a fantastic weekend, and I will see you all on Tuesday. All right, take care, everybody. Bye-bye.